Right, so since now that we understand what are functions, it's time to actually learn how to make graphs of functions, right? So in this lecture, we're gonna be focusing on what is a graph and how to plot a graph, right? So a graph is basically nothing but a method or a technique to represent data, right? So represent some data or information, right? So we understand what is data, and we just want to represent it on a piece of paper, and we use the technique called graphing, right? So we, talked about an example of functions like y is equal to x plus 3, and we actually talked about a function machine whose job is to actually add 3 into whatever the input is given to that machine. For example, you give it 4, it adds 3 to it, and y would be equal to 7, so the output is 7. So whatever you just input, uh, whatever the input you give into this function, you will get an output that is dependent upon that input. And we can just represent this equation. We don't have to use algebra, we don't have to use English alphabets, or this equation type of format. We can use the graph type of format, which is easily understandable uh, by any student of different fields, whether he studies economics, whether he studies biology, whether he studies any sort of field. So algebra typically is a mathematics thing. So most of the people won't like information to be written this way. They would want a graphical representation of data, right? So what I'm going to do is first of all draw an an axis system. So we also discussed the coordinate a Cartesian coordinate system. We're going to be taking help from that. So instead of making a whole grid, I'm just going to make the boundaries of this grid and represent this bottom left point as 0, and then going to scale it, label these grid points or coordinates as, for example, 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and so on. You could just go up to 9 and 8 here and so on, right? So this is an axis system. We call the horizontal line or axis to be x-axis and the vertical to be y-axis by convention. And now we just need to see how we can actually translate this equation into this graphical format. So first of all, we can draw a table. We can write y here and we can write x here, right? And then we can make a small table. And what we need to do now is to take some sample values of the function. For example, just like we did in that function machine, we added some arbitrary values of input, and then we got some uh, output values that were dependent upon them input values. So in this time, we're not going to use some arbitrary values, but instead the values that are already here on the axis system. So for example, x starts with 0, and then we can take 1, we can take, for example, 4, we can take 6, we can take 8, or whatever numbers you want to take here. And then you just need to see what is the output. So you put 0 into this function. What is the output? X is equal to 0, y would just be equal to 3, right? So 3. You put 1, what do you get? Y would be equal to 4. You put 4 in for x, you get 7. You put 6, you get 9. You put 8, you get 11, right? And so on. All we need to do right now is to, like just we did in the exercise of understanding the Cartesian coordinate system, we understood what are coordinates. We just need to plot these coordinates on this graph right now. So I'm going to use yellow color to plot the points. So first point is this: y is 3 and x is 0. So when x is 0, y is equal to 3, so the point is here. When x is 0 and y is 3, right? And then 4 and 1. When x is 1, y is equal to 4, so the point goes here. When x is 1, y is 4. Simple. This is the x-axis, this is the y-axis. And when x is 4, y is 7. So it goes something like 5, 6, okay, I missed 7, so 4 and 7, something like here. And you could just, draw all these points. Since I don't have much space here, so I won't be able to do that. But once you, draw all these points, if you just, plot for 2 and 3 as well, you will get a point system like these, and you could just take, in between values, and you will get all the points here, and you start to observe a pattern being made here. You start to observe that this is a line. This is a straight line that goes like this, right? So this is actually a representation of this function. This line here, this yellow line here, is actually the representation of y is equal to x plus 3. So that's how we draw graphs, and that's how we understand how to depict or how to translate the algebraic functions into the graphical, format. So this line here is actually representing this function. So you could just write y is equal to x plus 3, or you could just make a graph and draw a line which has a particular gradient, which has a particular slope. We will discuss what is slope and what is gradient, and it passes through or intercepts this y-axis at point 3. We'll also be talking about that in the future videos, but this is how you actually draw graphs. So the summary of this video is that if you want to draw a graph of a function, you need to have an equation. You just need to make a table, take some arbitrary values of x, which are basically your input, and then you just need to solve that equation for y, and you get some output values for those input values, and then you just simply need to plot those coordinates and then join those coordinates together to make a straight line, so you get a graph for your function. So that's how you draw graphs for your functions.